A sine wave passes through an angle of 1.34 radians in 14 milliseconds. Calculate the period of the waveform. First, we're supposed to always write everything whatever is given and what we're supposed to find. We have given angle, theta, which is equal 1.34 radians. We have time, 14 milliseconds, and we're supposed to find the period. Please remember that omega t, angular velocity times time, is equal angle, theta. I'm looking for omega. Why I'm looking for omega? Because omega, angular velocity, is equal 2 pi over t. Omega contains the period, and I'm looking for period. That's why I have to find omega first. In order to find omega, I have to divide both sides equation by t. T and t will cancel out, and I have omega is equal theta over t. Please notice that anytime you are going to deal with angles, you're supposed to be very careful, especially when you're looking for omega. Omega is measured in radians per second, so your angle has to be in radians. In our case, angle is expressed in radians. That's why I'm going to simply copy this down, and I'm going to write 1.34 radians over 14 seconds, which is going to give me 95.71 radians per second. This is my omega. We said that omega is equal to 2 pi over period. From this formula, I can calculate the period. Omega equals 2 pi over t. In order to find t, I have to solve this formula for t. I have to multiply both sides equation by t. T and t will cancel out, and I have t omega equals 2 pi. In order to find t, I have to divide both sides equation by omega. Omega will cancel out, and period is equal 2 pi over omega, which is going to be equal 2 pi over omega, which is equal 95.71 radians per second. 2 pi is expressed in radians. Radian and radian will cancel out. This is equal 65.64 milliseconds. This is the period, and this is the solution to my problem.